All right, welcome to my third video reviewing for the Florida B.E.S.T Algebra 1 EOC test using the 2024 released test. In this video, I'm going to cover the last 15 questions, numbers 31 through 45. If you find my videos helpful, please like, share, and subscribe. All right, let's go ahead and get started. All right, let's start with number 31. An artist earns a profit from selling Y paintings. His profit P in dollars is modeled with the given equation. P equals 200Y plus 23.25 minus 10.53Y. His profit is the difference in the amount of money he earns from selling his paintings and the cost of making the paintings. Which expression represents the cost of making Y paintings? So this sentence here tells us how we're calculating the profit. It says the profit is the difference. We're subtracting right here. And what are we subtracting? The amount of money he earns from selling the paintings and the cost of making the paintings. So our P profit equals the amount of money he earns from making the paintings, which is 200Y plus 23.25. So we can see here this 200Y. We can assume that the artist is charging $200 per painting, and this 23.25 might be a service fee. Minus what? Minus his cost, which is 10.53Y. So this is the artist's cost per painting, $10.53 per painting. So our answer is B. Moving on to number 32, cardiac output D is the amount of blood that the heart pumps per minute. The value of D can be found using the formula shown, where V is the amount of blood that the heart pumps with each heartbeat, and R is the number of heartbeats per minute. D equals V times R. Complete the equation to represent V in terms of D and R. So it says here V equals, so all we're doing is solving this literal equation for V, which means we need to isolate V. Now, in order to isolate V, we need to get rid of this R. What is R doing to V? It's multiplying it. And how do we undo multiplication? By division. So we're going to divide both sides of this equation by R. So here the R's cancel out, leaving us with V equals D over R. And that's our answer. Now you can see this keypad here. So a question like this on the test might be one where you have to enter this fraction D over R using this keypad. Our answer will be V equals D over R. Number 33, two divers are underwater. One diver is at a depth of 32 meters, while the other diver is at a different depth. The given equation can be used to find the possible depths x in meters of the other diver. Enter values to complete the sentence about the other diver's depth in meters. The other diver is at a depth of either blank or blank. So we're going to get two answers here. Now, what we have here is an absolute value equation. So it says here that the absolute value of x minus 32 is 11. Now remember that there are two numbers that have an absolute value of 11. The absolute value of 11 is 11, and the absolute value of negative 11 is also 11. So we can use that to write two equations. One equation is going to be x minus 32 equals positive 11, and the other equation is going to be x minus 32 equals negative 11. And all we need to do is solve both of these equations. So in the first equation, we add 32 to both sides, and we get x equals 43. And in the second equation, we add 32 to both sides. And in this equation, we get x equals 21. So these are our two depths for the other diver. The other diver is at a depth of either 21 or 43. Moving on to number 34, the equation of a linear function q and a table of values of a linear function r are shown. Which statement correctly compares the slopes and y-intercepts of the two functions? So since we're going to compare these two functions, let's just make a quick little table. So in here, we're going to put Q, and here we're going to put R, and here we're going to put M for slope, and here we're going to put B for the y-intercept. Now looking at the function q, this equation q of x equals 2x minus 1 is in slope-intercept form, which is y equals mx plus b. And that makes it very easy to identify the slope and the y-intercept. The slope is 2, and the y-intercept is negative 1. Now we need to find the slope and the y-intercept of function r. Now the y-intercept is easy to find. It is right here. Remember, the y-intercept is the value of y when x is 0. So our y-intercept is negative 2. And for our slope, we need to look at the rate of change. So the rate of change for x is plus 1 each time. And the rate of change for r of x, or y, is plus 6 each time. So our slope is 6 over 1, or just plain 6. So now looking here, we see that r has a greater slope than q, and q has a greater y-intercept than r. So which one of these statements states all of this correctly? If we look at statement B, it says function r has a lesser y-intercept, which is true, negative 2 is less than negative 1, and a slope that is 3 times the slope of function q. The slope of r is 6, and the slope of q is 2, and 2 times 3 is 6. So that's also correct. So our answer is B. All right, question 35 says a system of inequalities is given. X is greater than or equal to 5, and y is less than negative 3. Which graph represents the solution set? So we did a problem similar to this one in a previous video. The inequality x is greater than or equal to 5 is related to the linear equation x equals 5, which is a vertical line that goes through the x-axis at 5. And since this is an or equal to, that means it's going to be a solid line. So which one of these graphs has a solid vertical line that goes through the x-axis at 5? And we can see that that's going to be A and C. B and D are already wrong. We don't need to worry about them anymore. Looking at the second inequality, y is less than negative 3 is related to the equation y equals negative 3, which is going to be a horizontal line that goes through y, the y-axis, at negative 3. And since it's not or equal to, it's going to be a dashed or dotted line. And looking at A and C, they both have the correct line for y is less than negative 3. So now all we need to do is determine where the shading belongs. For x is greater than or equal to 5, when we have a vertical line, greater than is to the right of that vertical line. So we're looking at going this way. And for y is less than negative 3, when we have a horizontal line, less than is below the line, so we're looking at going this way. And we're looking for where the shading overlaps, which is right here in this lower right-hand corner, which makes graph A the correct graph. All right, number 36, an equation is shown, x squared minus 15x equals negative 14. What are the two solutions to the equation? Now, there are many ways to solve a quadratic equation. The first method I want to show you is to solve by factoring. Now, when we solve a quadratic equation by factoring, we need to set the equation equal to 0. So we can easily do this by just taking this negative 14 and moving it right here. Now, whenever we move a term from one side of an equation across the equal sign to the other side, all we have to do is change the sign. So we get the equation x squared minus 15x plus 14 equals 0, and now we can go ahead and factor. So remember that the third term in a trinomial comes from multiplying two numbers together, and the middle term in the trinomial comes from adding those same two numbers together. So we're looking for two numbers that multiply together to make positive 14, and when we add them together, we get negative 15. So what could those numbers be? This might be a little tricky, but it's actually not that difficult. Our numbers are negative 14 and negative 1. Negative 14 times negative 1 is positive 14, and negative 14 plus negative 1 is negative 15. So we can factor x squared minus 15x plus 14 as x minus 1 times x minus 14 equals 0. So then by the zero product property, we know if A times B equals 0, then either A equals 0 or B equals 0. So now we go ahead and we write these as two separate equations. One equation is going to be x minus 1 equals 0, and the other equation is going to be x minus 14 equals 0. Then we just go ahead and solve both equations. So here, when we add 1 to both sides, we get x equals 1. And here, when we add 14 to both sides, we get x equals 14. So those are our two answers, 1 and 14. Another method we can use to solve this quadratic equation is quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And in order to use quadratic formula, we need our equation set equal to 0, which I already have done here. And we also need to be able to identify a, b, and c. So remember that a quadratic equation in standard form is ax squared plus bx plus c equals 0. So we see here that our a value is the coefficient of x squared, which in this case is a 1. Our b value is negative 15, the coefficient of x, and our c value is 14. Then I always recommend to my students to set this up using parentheses, because parentheses keep us from making silly mistakes. So negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And we're going to go ahead and plug in our numbers. The first two parentheses is our b value, which is negative 15. So we put in here a negative 15 and a negative 15. Our next parentheses and the one on the bottom is a, and that's 1. And our last parentheses is c, and that is positive 14. Now the rest of this is just PEMDAS. So negative 15, that's positive 15, plus or minus the square root of negative 15 squared is 225, and negative 4 times 1 is negative 4, times 14 is negative 56. And on the bottom, 2 times 1 is 2. Now, we just have to do 225 minus 56. So we get 15 plus or minus the square root of 225 minus 56 is 169 over 2. And then we need to find the square root of 169, which is 13. So we get 15 plus or minus 13 over 2. Now, since we have the top of this fraction is 15 plus or minus 13, this now writes as two separate fractions. One fraction is going to be 15 plus 13 over 2, and the other fraction is going to be 15 minus 13 over 2. So over here in this first fraction, 15 plus 13 is 28, and 28 divided by 2 is 14. And in the second fraction, 15 minus 13 is 2, and 2 divided by 2 equals 1. So we can see once again we got the same answers, 1 and 14. Number 37 says a function f is given. F of x equals x squared plus 12x plus 20. Select terms to describe the end behavior of the function. So you would think, wait, don't I need to graph this? But we don't really need to. All we need to do is remember the nature of quadratic functions. So remember that this is ax squared plus bx plus c. And what we know about quadratic functions is that when the a value is positive, that the quadratic function, the graph, is a parabola that opens upward. And when the a value is negative, then the graph of the quadratic function is a parabola that opens downward. So we can see here that this quadratic function, the a value is positive. It's a positive 1, so it's going to open upward. So it says as x approaches negative infinity, that means as we move to the left. So as we move to the left on this function here that opens upward, what's happening to y? We're going up. So as x approaches negative infinity, f of x, which is y, approaches positive infinity because we're going up as we move to the left. Then on the right side, as x approaches positive infinity, so now as we move to the right, what's happening? The same thing, it's going up. So f of x approaches positive infinity as well. All right, number 38. The expression cubed root of 18 times 5, the cubed root of 6, is equivalent to 15, the cubed root of x. What is the value of x? So let's go ahead and take this expression, cubed root of 18 times 5, the cubed root of 6, and let's go ahead and multiply and simplify. So we can take this and rewrite this like this. 5 times the cubed root of 18 times 6, and 18 times 6 is 108. So this becomes 5 times the cubed root of 108. Now we can simplify this because 108 comes from 27 times 4. So this becomes 5 and the cubed root of 27 times 4. And 27 is a perfect cube. So now we can split these up and we have 5 times the cubed root of 27 times the cubed root of 4. And the cubed root of 27 is 3. So this becomes 5 times 3 times the cubed root of 4, and 5 times 3 is 15. So we end up with 15 times the cubed root of 4. So x is 4. All right, number 39. Margot surveys 150 high school juniors and seniors about their favorite types of dipping sauce. She records the results in the table shown. How many more high school juniors and seniors chose honey mustard sauce than sweet and sour sauce? So all we're looking for here are the totals for honey mustard and sweet and sour. So honey mustard, 26 juniors and 22 seniors for a total of 48. And sweet and sour, 11 juniors and 12 seniors for a total of 23. So then they just want to know how many more chose honey mustard than sweet and sour. So we're just doing 48 minus 23, which is 25. So that is our number 40. The graph of y equals f of x and a table of values for an exponential function y equals g of x are shown. Which statement correctly compares the graphs of the functions? So let's go ahead and compare these ourselves. And let's take a look at y equals f of x, and we could find the slope and the y-intercept. Our y-intercept is 1, and our slope, if we go from this point to this point here, we're going up 7 and right 2, which we could also write as 3.5. So we can say f of x equals 3.5x plus 1. And over here, they tell us it's an exponential function. So if we look at the pattern, here the pattern is we're multiplying by 2 each time. So here we could say g of x equals, and our initial amount is 1. So g of x equals 1 times 2 to the x power. Now, just understanding the nature of exponential functions, and this is an exponential growth because our b value is greater than 1, that since we're multiplying by 2, eventually this exponential function is going to start increasing faster than the linear function will, just by understanding the nature. But to prove the point, let's go ahead and say what will happen on this graph. Compare both of these functions when x is 4. So over here, when x is 4, so we're going to say here f of 4 equals 3.5 times, and we're going to substitute 4 for x, times 4 plus 1, and 3.5 times 4 is 14, and 14 plus 1 is 15. All right, so in this function, when x is 4, f of x, our output, is 15. How about over here? If we say here, g of 4 equals 1 times 2 to the 4th power, well, 2 to the 4th power is 16. So here, in this function, when x is 4, our output g of x is 16, which we can see is already more than the output for f of x. So the correct answer here is A. As the values of x increase, g of x will eventually be greater than f of x. All right, number 41. Sanjay buys X boxes of hot wings and Y bottles of soda for a party. The numbers of boxes of hot wings and bottles of soda he can buy with $40 can be represented with the inequality shown. 40 is greater than or equal to 6x plus 2y. Which graph represents all possible solutions for x and y? So you can see here that all of these lines are in the same place. All we're really looking at is it going to be a solid line or a dashed line, and where is the shading going to be? But let's go ahead and just go through the steps of solving this really quickly anyways. First thing I want to do to make this a little easier to understand is I'm going to flip this around. So I'm going to put 6x plus 2y on the left and 40 on the right, and to make sure that the symbol's correct, the open part of the symbol is facing the 40. So that's going to look like this. So we have 6x plus 2y is less than or equal to 40. And if we use the x and the y intercepts, if we make y 0, this 2y part goes away, and we get 6x is less than or equal to 40. When we divide by 6, we get x is less than or equal to 6.7, because it's 6.6 repeating. On the other side, if we make x 0, this 6x part goes away, and we get 2y is less than or equal to 40. And when we divide by 2, we get y is less than or equal to 20. So we can see that our x-intercept is 6.7, and our y-intercept is 20. And all four of these have the y-intercept of 20 and the x-intercept of 6.7. So that's not the case. The case here is what kind of line do we use and where do we shade? So this is or equal to, which means we're going to use a solid line. So that means our answer has to be either A or B. And it is less than. So where are we going to shade for less than? So on this line here, we shade less than under or to the left of the line. So our correct graph is graph A. Number 42. Janelle buys blackberries and raspberries to make pies. Blackberries cost $8 per pound and raspberries cost $9 per pound. Janelle can spend a maximum of $40. Create an inequality to represent how many pounds of blackberries B and raspberries R Janelle can buy. And you can see here by this keypad in the bottom, a question like this on the test, you would have to enter the inequality using the keypad. So we have blackberries are represented by the letter B, and they cost $8 per pound. So we could say 8B, which is the amount of money spent on blackberries, plus raspberries are $9 and per pound and are represented by the letter R. So we could say 8B plus 9R. 9R represents the total amount of money spent on raspberries. And Janelle can spend a maximum of $40. That's the most she can spend. But does she have to spend $40? No, she can spend less if she wants to. So that is going to be less than or equal to 40. And that's our inequality. All right, number 43. Cynthia buys some tools. She creates an exponential function v to predict the value of her tools after 2 years. She predicts her tools will have a value of $380 after 1 year and a value of $361 after 2 years. Which equation represents a function? So we see that the value of her tools is going down. So this is an exponential decay. And the equation for an exponential decay is y equals a times 1 minus r to the t power, where a is the initial amount and 1 minus r represents 100% minus the percent of the decay, and the t power is the amount of time, in this case the number of years. So what we're looking for here is what is going to be our percent. Since it's a decay, right, our percent is going to be a number less than 100%. So what is going to be our percent? We can do that very easily by taking a y value, like 361, and dividing it by the y value that came before it, 380. So if we do 361 divided by 380, we get 0.95, which is 95%. So each year, the tools have a value of 95% of the year before. Now, how do we write that in terms of 1 minus r? That's going to be 1 minus 0.05. So we see that it's got to be either A or C. So we have that 1 minus 0.05. The question is, what is our initial amount? What value did the tools start out with? 400 or 380? And if you look closely, it says the tools will have a value of $380 after 1 year. That means she's already had them for a year, which means they had another value before that. So we can't have $380 as our initial amount. It's going to have to be 400. But just to check, if we do 400 times 0.95, guess what we get? We get 380. So our initial amount, the value of the tools when she first bought them, was $400. So the answer is A. V of t equals 400 times 1 minus 0.05 to the t power. All right, number 44. The graph of a quadratic function is shown. Which equation represents the function? And we see here that all of these equations are in vertex form, which is y equals a times x minus h squared plus k. And h is the x value of the vertex, and k is the y value of the vertex. So we're going to go ahead and plug these in using parentheses. So we have x minus a parentheses for h plus a parentheses for k. When we look at our vertex is at the point -3, 4. So we put a -3 here and a 4 here. We clean it up a little bit. We get y equals a times x plus 3 squared plus 4. Now we need to figure out what our a value is. And we're going to do that by plugging in one of the other points that we have. So let's go ahead and take this point here, which is -2, 2. And so we're going to do this. It's going to look like this. And we're going to put our x value, -2, right here, and our y value, +2, right here, and we're going to solve for a. So we have 2 equals -2 plus 3 is 1, and 1 squared is 1, and 1 times a is a. So this becomes a plus 4. Then we subtract 4 from both sides. And we get a equals -2. So then we just come back here, y equals a times x plus 3 squared plus 4, and we substitute a -2 for a. So the correct equation is y equals -2 times x plus 3 squared plus 4. And that is option A. All right, our last question, number 45. Select all the values that are equivalent to radical 24 over radical 8. So let's go ahead and write this here, and let's go ahead and simplify these. So I could rewrite radical 24 as radical 4 times 6, and I could rewrite radical 8 as radical 4 times 2. We'll split these up. We get radical 4 times radical 6 over radical 4 times radical 2. And the square root of 4 is 2. So the top here becomes 2 radical 6, and the bottom here becomes 2 radical 2. And so we see that that is right here, option D, 2 radical 6 over 2 radical 2. So that is equivalent. But is there anything else equivalent? Well, if we take a look at this and we work this out, what's 2 divided by 2? 1. And what's radical 6 divided by radical 2? Radical 3. So 1 radical 3 or just radical 3. So that makes A is also the correct answer. So it is A and D. All right, this is the end of the video. I hope that you have found all of my Algebra 1 EOC review videos helpful, and I wish you the best of luck on your test. Please remember to like, share, and subscribe, and I'll see you next time.